Hello and welcome back to Mr. Lamb Science Corner. Today we're going to do a little demonstration that could turn into a lab if you wish. It might be considered a little too far advanced for fifth graders, but I don't think so. I think you can do it with some work, and that is talking about calories. Now, calories is something we've talked about before. Basically, a calorie is a metric unit of how much heat is necessary to raise 1 gram of water 1 degree Celsius. The English equivalent's a BTU, British thermal unit, which is 1 pound of water 1 degree Fahrenheit, raised up 1 degree Fahrenheit. So it's a much larger unit because while 1 degree Fahrenheit's a smaller unit than Celsius, a pound is certainly a lot more than a gram. So anyway, so we have calories, and most of the time with the fifth graders or equivalent, you're going to talk about probably food calories, which is a kilocalorie, which is 1,000 regular calories, because a regular calorie is a very small number. And if we're going to talk about only being able to eat, well, for adults somewhere between 1,500 and 2,500, and for kids about 6,000 calories. That isn't very much, but 6,000 units of 1,000 calories each, that's a fair chunk of change. So anyway, it's hard for kids to understand that this represents heat. You know, they talk about calories, and a carrot stick has 2 calories, and a Milky Way bar has 14 million calories. It seems like probably only about 1,000 or so, maybe even less, but it seems like. And so to get this across, what I've done is I've taken a common ordinary paper clip and bent it around to where I get a shape like this, with a little stand. Now, if you want to do this as a demonstration, this is going to be enough. Now, I did try, I purchased some ceramic discs or squares. They're very, very cheap, and I can't find them now. So I'm going to break every safety rule that I have, and I'm going to do this on a wooden table. But it's not a whole lot of heat. So anyway, so visualize, if you will, a ceramic square right here. These are very nice. I bought some down at the local hardware store for about 25 cents a piece, and I used them all the time, but I left them at my high school. So I bought some more and then put them, Lord only knows where. So if you want to do a demonstration, take a paper clip, bend it into a shape where it makes a little stand like this. If you want to turn it into a lab, get some kind of stand, which I don't have, and put a little beaker of water here. Measure the temperature of the water at start. Light the peanut on fire. We're going to burn a peanut. Let it burn. Weigh it beforehand. Weigh it after. And then with the amount of heat measured by how hot the water gets, and you can do a calculation there. And we can also do a calculation from how many grams was consumed, and we can measure up the amount of heat that is in a peanut, and you get kind of a rough idea of how much energy, because heat is energy. Yeah, so if you want, just as a demonstration, it does take a little bit to get it going. And there we have the burning peanut. So, like I said, you would measure this out. While this is burning, we'll do we have our friend the equation Q equals mc delta T, where Q is heat, M equals mass, C equals something called the specific heat, and delta T is the change of temperature. And I'll hold this up here. Q equals mc delta T. Delta T runs together. Q is how much heat. So how much heat is this peanut giving off? It's the same amount of heat giving off burning here as would give off inside your body. And just as we'll have a little bit of ash here, you'd have a little bit of ash in your body, which comes out as number 2. M is the mass of whatever is giving off heat. The specific heat I'm going to introduce a new symbol. C, specific heat, is defined as, and I think I was in college when the professor insisted that this was the symbol that was used to show definitions. And it's a measurement of the heat necessary to raise 1 gram of a substance 1 degree Celsius. Okay, and my peanut just burned out. Some peanuts work better than others. We'll see if we can get this relit. But it's okay if it went out and it's obviously not burned all the way, because you're going to measure a mass difference. And how much of it burned versus how much heat did it give off. And so you would use this equation here to measure how much heat is gained by the water. So 100 grams of water, 100 milliliters of water, the specific heat of water this is the definition I actually wanted to get. The C of water is defined as 1 calorie per gram degree Celsius. So 1 gram of water raising up in temperature 1 degree Celsius, that is what 1 calorie is. It's not very big. See, there it goes. It's really burning now. And this is because you need to have one specific heat defined. Because what you're also going to do, and I know I'm getting a lot of math in here, so you probably aren't going to want to do this with 5th graders, but you know, who knows, with high school students maybe you will want to do it. I'm going to give you the world's easiest equation. Q lost equals Q gained. The amount of heat lost by one object is the amount of heat gained by another object. Okay, so this is losing a certain amount of heat in the burning peanut, and the water is gaining the heat. Right now we have the air is getting warmer, and if I wanted to stick my hand over this and go, oh, that's nice and warm, then my hands would be gaining the heat. But how can my hands gain heat unless something else loses the heat. So we have the equation, Q lost equals Q gained. And then we have one more equation, and that is where Q equals mL sub F. Amount of heat, mass, in this case now, of the object in the latent heat of fusion. So, probably getting deeper into the math than would be appropriate. We notice that the peanut went out again. And again, that's okay, because the peanut burns however much it does, and it's the weight difference that you're going to measure. But mostly what I would suggest is for elementary students is to have this as a demonstration, so they can look at the burning peanut and you tell them that it's not burning inside you, but it is giving off heat the same as, and they could, put their, you might have one or two volunteers put their hand out and and feel the warmth. Or you could just tell them that there's warmth there. Okay? Talk to you later. Bye.